Welcome everyone. Today's session is all about understanding one of the most fascinating concepts in deep learning, which is autoencoders and variational autoencoders. We will learn how they work, compare their workflows, and understand their use cases, and where actually we can use this autoencoders and variational autoencoders. So our today's agenda is to understand what is autoencoder. We'll have a deep dive into understanding about what is the architecture of this autoencoder versus variational autoencoders. So here, let's start our session. Before starting our session, we will first understand what is autoencoder. So an autoencoder is nothing but a neural network that learns to compress and then reconstruct the data from there. It's a form of unsupervised learning, which is used mainly for dimensionality reduction, for reducing the noise, and for representation learning. So here, in this autoencoders, we are having an encoder and decoder things. So what is there in the encoder means we will have our data, input data. So our input data can be in a form of images. It can also be in the form of textures. And then we are going to send, suppose we are taking an images, we are going to send the images here in the encoder states. With what is happening in this encoder means, in this network, the compression of the inputs will happen. And it will make the images, it will make the pixels into a complex or a compact representation, which is also called as what? Which is also called as latent space. So this is where the data is represented in a reduced format or in a compressed format. Now, what is the duty of decoder then? Decoder will decode it. What is actually present within this compressed network? So we are sending the images into the encoder. Encoder is compressing this particular image and forming the latent space. Then the decoder is using this latent space and decompression is happening and identifying that what is actually present within that images. Within that output, there will be some reconstruction output which will be there. Okay, so here this is your original input data. We are sending it to the encoder. Encoder will form some latent space representation, which is nothing but a compressed representation of the data. And then what will decoder do? So decoder will decode it, or it will do a decompression over this particular latent space. And in the output layer, we are going to classify what is actually present within that reconstruction output will be generated. Now, after reconstruction output is generated in this output layer, we will have a loss calculation. Loss calculations, either we can have a cross entropy function or a binary cross entropy function for identification of this loss function. Okay, here generally we will always going to calculate the reconstruction losses. What is the reconstruction losses? Reconstruction losses is nothing but the actual value, means the original input data versus that of predicted by our model. What is predicted by the decoder? So this is nothing but the reconstruction losses, which will be calculated by using a binary cross entropy or simply a cross entropy loss function. So once it is done, here's how our autoencoder part or autoencoder will be generated. Okay, once our model will be trained, how our model will be trained? When the loss, whenever the reconstruction loss will be minimized through the back propagation. Every time we are going back, again we are taking some latent space, again we are decompressing it, again we are predicting the output. Again the losses are being generated. So once this loss is minimized through the back propagation, the model will be trained. And now, what are the different use cases of this autoencoders? So this use cases of autoencoders are nothing but we can use it for image denoising. We can use it for anomaly detections in the time series data. We can use it for dimensionality reductions, like we use it principal component analysis, PCA. Likewise, we can use it. Then we are having a variational autoencoders. So in the variational autoencoders, what is the difference here means a variational autoencoder learns not just a single latent representation, but the distribution it will be learned. It uses a sampling and reparameterization tricks. So how it works? So firstly, we are having a variational autoencoders. So here in this variational encoder itself, we are not going to give the entire image here. What we are going to do, instead of directly outputting the latent code, it outputs two vectors. We will output two vectors here. First will be our mean and second will be the variance. So what will be here in the mean and the variance means it will represent the Gaussian distribution within the images. What is actually important within the images. So some sampling technique will be required here. Okay, by using this mean and variance, we will have our distribution, which is also called as Gaussian distribution, which will be there within our latent variance or a latent mean. Once this is generated, once the distribution is generated from the encoder layer, it will have a variational autoencoder sampling layer. Here we sample from the distribution using a reparameterization tricks. Okay, what is important here? What is important here? And every time we are going there, we are predicting some output. Again, we are back propagating. Again, we are changing it. Again, we are changing. Again, we are having a reparameterization trick. And again, we are taking a different distributions. So every time we are taking a sampling technique, we are having a different output altogether. Okay, so after having a sampling, variational autoencoder sampling, what we will do? Based upon that sampling, based upon that mean and variance and the distribution, based upon that, whatever the sampling we have collected, we will form a decoder layer. So what is happening in the decoder? Decoder is nothing but it will going to generate the output for you. So just like our autoencoder, but it will work with a sample latent vector. It will work with a sample latent vector. Here it was a compressed. Here what we were doing, we are having a autoencoder latent space, and based upon this compressed layer, we are just decompressing that layer. Here it is same, but here instead of latent space, we are having a sampling. And then it will going to, based upon this, it will going to generate something. Decoder will generate something. So whatever it will be generating, it will be a reconstructed version of this original input data. Reconstructed version. Okay. Why we are calling this as a reconstructed version? Because here itself we are not going to take the original input data. We are taking just a mean, or we can say we are only going to take a distribution part from this particular input. And from that, based upon reparameterization techniques, we are just having a sampling thing. Okay. So based upon this, we are having a loss function as well. So here, instead of having only a reconstruction loss, we will also have a latent loss. Okay, here we are having a reconstruction loss. Along with reconstruction loss, we will have a latent loss. Latent loss is nothing but because of sampling, because of reparameterization trick, whatever suppose the input we have missed. So based upon that also some losses will be taken. So both the losses will be considered, reconstruction losses and the latent losses. Now, once the losses is minimized, how the loss will be minimized? By using a backpropagation tricks. Again, we will going to use a reconstruction, reparameterization trick. Again, some new distribution we are going to take. Again, we will have a decoder. Decoder will generate something. Again, we will have a loss function. So once the losses will be reduced, we can use it for model training. So now for what purpose we can use this variational autoencoder means this is nothing but a generative thing. We are going to generate something from here. Okay, based upon some sampling, based upon some latent random vectors, we are going to generate something from them. So we can use it for face generation. We can use it for text interpolation. We can use it for some drug discovery. Likewise, we can use it for different purposes. So to sum up all together, we will understand what is there in the autoencoder versus what is there in the variational autoencoder. So autoencoders are nothing but it is a compression and decompression technique. Encoder will compress the output and it will form a latent space representation, and decoder will decompress it and form the output file. And hence, by doing this, we will have some losses, which is also called as reconstruction losses. In the variational autoencoders, they are more flexible and generative, making them ideal for creating a AI application. We can use it for generating something from here. Okay, I hope it is understood. Very simple concept. So we'll just walk through a coding part for here. So here we are just using our TensorFlow framework. We are importing our TensorFlow. We are importing from TensorFlow. We are importing layers and models. We are importing NumPy for numerical calculations. We are importing Matplotlib for visualizations. Okay, so here we are taking directly our data set from tensorflow.keras.dataset. Once you will surf about this, within our tensorflow.keras, we are having a dataset folder. Within this already, this is a publicly available dataset, MNIST dataset, which is nothing but a digits dataset. Okay, which is already available in this Keras library. Okay, within the dataset folder. So we are just calling it from here and we are importing this particular data set. So here, as you can see in the training and the testing data set, we are having 28 by 28 by 1, which is a black and white images. The depth is 1, the channel is 1. That means it is not a colored image. It is a black and white images. Okay. Then we are defining our architecture here. We are defining our autoencoder architecture wherein we are taking our input images. Here we are taking our input image, which is 28 by 28 by 1. We are calling our layers from the Keras library. We are calling the layers and we are having our input image. We are having a dense layer. We are using a 128. 128 is nothing but this is a part size we are taking. And here we are having an activation function which we are using as a ReLU activation functions. Okay, and here we are making into some dense layer. Layers.dense will make it into one single dense layer. Okay, after that, here we are using a loss function. We are using a loss function of binary cross entropy, and optimizers we are using as an atom. So whenever we are having a model.compile, here the variable name we have given for this model is autoencoder. So that is why we are calling model name is autoencoder.compile. Will have our optimizers and the loss function. Once we want to train this particular model, we have to write model.fit. Model.fit will do what? It will run the epochs with the particular path sizes. Okay, so we are using this and we are running 10 epochs. After running all the 10 epochs, we are getting the image like this. This is our image which is generated from here. Okay, so for visualization, we have used our Matplotlib. Okay, then in the variational autoencoder, instead of giving the original images, instead of giving the original input image, we are having a latent dimension, which is 2 we are taking. And we are initializing our class labels as variational autoencoder. Within that, we are having encoder and decoder altogether. We are calling our encoder and decoder. We are again compiling our model. We are again fitting our model with the 10 epochs with a path size of 256. And then we can see the output, what is being generated from the variational autoencoder. So this is being generated from this variational autoencoder part. So you can see the output is the degraded output. This is not the actual output. This is the degraded output since it is being generated from only 2 latent space. We have used only 2 latent space. Based upon that 2 latent space, it is generating the output. So if we will increase more latent space, maybe it will generate a better output. So now here in this, we are having 2 losses. We are having our reconstruction losses. Along with reconstruction losses, we are having a latent loss also. So both the losses together we are taking. So at the end of all the 10 epochs, we are having the losses, which is both equals to this. Okay, so whenever we are using our autoencoder also and variational autoencoder also, the output which is generated, which will be the degraded output only. Okay, so hence I have told you we can use it for different purposes. We can use it for generating human-like images or for generating some images which will be closer to each other. If we want to generate, we can use it for data augmentation techniques and so on and so forth. So this is it from my side for today, guys. We will meet with a new topic in the next lecture. Thank you for joining. Before dropping off, I also want to tell you that if you want to reach a particular folder, this is our contact number. You can reach here. Okay, we are here in the we have having a inquiry at 360digitmg.com. You can go and surf here also. These are all our headquarters, which is in Hyderabad, Bengaluru, Chennai. We are also having centers in Pune, Thane. We are having centers in multiple states, multiple cities we are having. So you can go and surf in our website. You will get better understanding. Thank you for joining, guys. We'll meet with a new topic in the next lecture. Thank you once again.